Happy Friday. Happy Friday before a 3-day weekend. Happy Friday before a 3-day weekend. I'm going to get him into a augmented matrix, okay? We switched these two, right? That's how we did it? Okay. Could we get in some pretty big trouble if we don't write down the correct values, guys? Yeah, right? Oh, that could be awful. But why was it nice that we switched the first row with the bottom row? We already have a 1. We're working by columns, just like we did in section 7.2, 7.3, wherever that was. We need to eliminate the x's first. We need to eliminate the x's first. There's our augmented matrix, our 4x4 with variables, and then our constants. If we're trying to work with the variables first, we don't mind him being there with a 1x and then the rest of whatever that equation is. But I do mind this guy, and this guy. What's nice, as soon as we have the established 1, we can get our zeros where we need them just by multiplying row 1, which we're keeping because we like that 1. We don't mind that 1. We can use row 1 and say, hey, I need the opposite, so negative 1 times row 1 plus row 2. Or we can multiply by the opposite, so 2 times row 1 plus row 3 into row 3. Or we can multiply by the opposite, negative 3 row 1 plus row 4 into row 4. How do we get zeros? We multiply a 1 by an opposite and then add. How do we get zeros? We multiply whatever row had the established 1 by the opposite coefficient, and we add. So how do we get 1s? We divide, but we didn't need to this time. We could have had our computer still divide everything in row 1 by 1. We could have, but we didn't need to. So how do we get zeros once we have the established 1? We multiply that row, row 1, by the opposite with addition. So starting off here, if I multiply by a negative 1, negative 1 plus 1, 0. Booyah. Remember, we have to multiply every entry in row 1 by that coefficient and then add. So negative times 1 is negative 1 minus 1 is negative 2. Negative times 1, negative 1 plus 4 is 3. Negative times 1 is negative 1 plus 2 is 1. Negative 6 plus 25 is 19. Pause. Questions about my row 2? You should. It'd just be a little awkward, but I guess you could do 1 times row 1 minus row 2, negative 2 times row 1 minus row 3, 3 times R1 minus row 4. I just like, since I'm multiplying anyway, to do a negative, but you could technically multiply by the exact same and subtract. It will always get you a 0. Yeah. Because technically equations, like in elimination, for instance, if you're like taking two equations and adding, subtracting, you could technically flip the order. It's not going to change the balance. Does that make sense? Yeah. Well, the reason that we did that, just because we're not a computer, well, first of all, we saw yesterday our computer program always takes the bottom one for whatever reason. I don't know why the programmer did that. The programming in your calculator always chooses the bottom, but also you as a non-computer, you could say like, oh, stink, I have to get a 1, I have to divide by 3, divide by 3, divide by 3. See how that would have gotten us nasty fractions from the very beginning? Since we're not a computer, it's like, oh, I like him a whole lot better to start me off. Okay. But Gavin, technically, if we hadn't switched, even though you would have had nasty fractions, all roads should lead to it just might be a messier road. Does that make sense? Oh, sorry, we need to see this matrix in order to keep going. So then as we go to this one, 2 times row 1. 2 times 1 is 2, minus 2 is 0. 2 times 1 is 2, plus 1 is 3. 2 times 1 is 2, plus 2 is 4. 2 times 1 is 2, minus 1 is 1. 2 times 6 is 12, plus 2 is 14. Double check my math. Let me know if something doesn't measure up. Now I'm going to go to the next one and do the exact same thing, but I do want to highlight something, because remember how yesterday I said some of you, this is a lot of mental math, right? What you could do, just as an example for each one of these if you want, and I've had kids before that have had a whiteboard off to the side, or have had a scratch piece of paper off to the side, like 2 years ago, 3 years ago. Kids who were able to get all the way through Calculus AB and pass the AP test, but would acknowledge that they had weaknesses in different areas of algebra, factoring, foiling, mental math. This is how they got this done. You could come off to the side. Who is them? And they would to the side and say, okay, I'm going to multiply negative 3 times. I'm going to get negative 3, negative 3, negative 3, negative 3, negative 18. They would actually do the little math as a little baby off to the side work. So they multiply all of row 1 entries, and then they take all of R4, 3, 2, negative 1, 1, 0. And guess how many mistakes they made? Very few, if any. Why? They did what they needed to do to get it right. See? And we can do it, because that would be 0, negative 1, negative 4, negative 2, negative 18. Does it take a second more? In some ways, but in some ways you don't have to second guess that what you're doing is right. You can throw in 0, negative 1, negative 4, negative 2, negative 18. Doesn't mean you can't still make a mistake, but man, it will be cut down. Are some of you seeing what you could do? And you don't have to show all this on your homework. It could get really messy. But a whiteboard's super nice, super easy, super clean. Even a little baby one. Sub piece of paper, also cool. For my mental mathers, though, we could have totally done negative 3 times 1, negative 3 plus 3, 0, times negative 3 plus 2, negative 1. Negative 3 times 1, negative 3 minus 1, negative 4. Negative 3 times 1, negative 3 plus 1, negative 2. Negative 18 plus 0. Got it. Have I eliminated all my x's, leaving one equation with one x? Yeah. So what's my next objective? Column 2. Let's go work on the y's. Does that make sense? Now, we could call this row 1, row 2, row 3, row 4, row 5, row 6, row 7, row 8, or we could just say row 1, row 2, row 3, row 4. I don't want to keep on renaming every single row, so if you guys don't mind, we're going to cover up the old one and just use the new one. Does that make sense every time? Okay. Adam, your question before we go tackling the second column.
Can we switch the two equations? Can we switch the new row 4 and the row 2?
Technically.
So that we get an extra one?
Now the dilemma is the more creative you are, the higher chance that there won't be someone else in the class that did the same thing. So finding your mistake might be harder if you make one. Does that make sense? But do you guys just hear what Adam said? He was like, can't we just switch those two? Why does he want to switch those two? What do we need in column 2 to begin? We already have our x1. What do we need now? Our y1. Ooh, we're going to have to divide by negative 2. Oh, fractions. What does Adam see? There's a 1. So you guys get to choose. Do you want to follow the firm, fast? Because this one, it's like, well, the calculator used the bottom row. We can use the bottom row. Now it's time to either be human or be calculator. Do you guys want to go for this the way it is, dividing by 2, negative 2, or do you want to go swap rows? Okay, give me just 1 second. Go to matrices on your calculator. Do you hear how I just used the word swap? Go to matrices on your calculator. I want you guys to go to that math menu. Isn't there a math menu? Can you scroll down and see if maybe any of these things are shown in that math menu of what you can do with matrices? Row swap? Oh! Is that a thing? Do you see row plus and row minus and row times? These things that we're doing, technically do on your calculator, but to be honest, I think it's a whole lot easier to do it by hand. If you're using the calculator, why not just go RREF, am I right? But if you're doing it by hand, why not just do it by hand rather than learn all the programming language? If some of you guys maybe want to go learn all the TI programming language in that menu, sure, maybe. Just a warning, it'll take a lot more work than just doing it by hand. But row swap, is that a valid option? Yeah. So, if you guys don't mind, let's be humans, not calculators, and say, this is easier. What am I row swapping? Technically, row 2 with row 4. Right? So, okay, let's take a second. I'm going to do 0, 0, 0, because they all have zeros. But now I need to write this guy. Well, hold on. Row 1 didn't change. Did I do too many? No, I didn't. The right amount. -1, -4, -2, -18. Wait a minute. Can I just kind of do a negative row 2 right now? Is that okay? Because I want a 1, so let's just take away all those negatives. Ha. Okay, sweet. So I swap the rows and I multiply that guy by a negative. Now, hold on. This guy's next, so 3, 4, 1, 14. And that guy's next, -2, 3, 1, 19. Just a warning. If you don't follow steps, if you don't make sure that each of what you're doing, each process, each little baby equation, if you're not following our system, it could very well end up messing up. It could end up messing up what you want to get to. Meaning, if you don't get a 1 first and then go get zeros, you could very well mess up your first column that you don't want to change. So follow our system. There's a reason for it. Get the 1 first. And once you get the 1, well, hold on, guys. We wanted a 1x with the rest zeros. Now we want a 1y with the rest zeros. Even him? Yeah, REF, not just REF. We want zeros for everybody else in the column. So guess what I'm going to do? I'm going to leave row 2 the same. Why? Because I need to use that 1. How do I use that 1 to get zeros? I multiply row 2 in every single one of these by the opposite of what I need to eliminate. So what's the opposite of 1? -1 to get my new row 1. What's the opposite of 3? -3 to get my R3. What's the opposite of -2? +2 to get my row 4. Pause. Do you see the system? We're multiplying whatever row has the established 1 by the opposite and then adding. Because -1 times plus, -3 times plus, +2 times plus, the opposite times the established 1 plus the row will always get zeros. Wait, we don't want to mess up our column 1 though, but pause. What's anything times 0? 0. Oh, sweet. So all of these times 0 plus 1, well, that's going to stay the same. 0 plus 0, oh, that's going to stay the same. And 0 plus 0, oh, that's going to stay the same. If you follow our system, you're not going to mess up what you've already finished. Okay. I'm going to go mental math style if it's okay. But some of you just know in the back of your heads when you're doing it on your own, you can go off to the side. Now the nice thing is anything times 1 is itself. So I'm just going to take the coefficient. So -1 plus 1 is going to be 0. -4 plus 1 is going to be -3. -2 plus 1 is going to be -1. And -18 plus 6 is going to be -12. Double check my rows, please. -3 plus 3 is going to be 0. -12 plus 4 is -8. -6 plus 1 is -5. -18 plus 14 is -4. Last but not least, 2 times 1, 2 minus 2 is 0. 8, 2 times 4, plus 3 is 11. 4 plus 1 is 5. And 36 plus 19 is 55. How we looking? Hey, anybody have the same thing? Give me a thumbs up.
We changed the first row because we want to get to reduce row echelon.
Because if we want row echelon form, we could just go 1s and 0s, but the problem with 1s and 0s, how much work is still left at the end? You have to do that whole back substituting thing again and again and again and again. If we can do our REF, at the end we'll have 1x equals 1y equals 1z equals 1w equals done. Is column 2 done? Yes. You guys going to trust Adam and I that we're good? Robbie says yes. Kathleen? Yes. I'm multiplying everybody here by -3, which 0 and 0. -3 plus 3 is 0. -3 and 4. -12 plus 4, -8. -6, -3 times 2. -6 plus 1, -5. And then -3. Oh, the -4 is off. Thanks, Kathleen. -3 times 18 is -54, and -54 plus 14 is -40. Thank you, kiddo. I was doing the -1 for some reason in my head. The nice thing is for you guys, since you don't have to like cover your body, cover part of the work to do it, you don't have to keep memorize what your formula is. You can keep looking at -3 times plus, -3 times plus. You can be looking on your paper and repeating the formula. That's safe. Thanks, Kathleen. Now we good? Okay. It's time to go with column 3. Column 3. Here's the sad thing. Do I have a nice little 1 waiting from the 2 that are left? No. And I don't want to go switching any of these because no. Those are good. Those are good. Don't switch them. I have my 1x, my 1y. All right. It is what it is. We need to get the established 1. So the crazy thing is that we're going to leave row 1 just as it is. I can't deal with him yet. I need to get the 1. We're going to leave row 2 just as he is. Row 3 is who I'm changing. The rest of them, they're going to stay. So how am I going to get my 1 in row 3? No. As soon as you multiply and add to get a 1, you're going to mess up somebody in these 2 columns. You have to divide. So we're going to do -1/8 times row 3. This is what we were looking at yesterday, how to get 1s versus how to get 0s. To get 1s, we're going to divide by the coefficient. And the reason is, if we do anything creative, adding, etc., if we get too zoomed in and hyper-fixated on this one, oh, there's a good life lesson in here. If we get too hyper-fixated on, okay, I can make this a 1, I can force it to work, I can multiply him by 2 and add it, that'd be a 0. If you try to do some sort of addition, you're going to mess up the bigger picture. If you get too focused on one little baby detail, you lose sight of the whole thing and you're going to end up messing it all up. So we have to keep remembering our system. We have to remember the truth behind what we're supposed to be doing. To get 1s and to get 0s. To get 0s, we add the opposite. To get 1s, we divide. Why? What's 0 divided by negative or times -1/8? Aha! He's safe. What's 0 times 0? He's safe. We need to keep these columns safe. But, here we go. What's -8 divided by or times -1/8? Whew! There's my 1. I know, but it's okay. It's okay. We got to do what we got to do. What's -5 divided by -8? Positive 5/8. It's okay. And what's 40 divided by 8? Oh, that's positive. Sorry, negative divided by a negative is a positive 5. It's okay. We're good. It's going to be a little bit messy, but we're all right. Remember, the point is to understand the system or the approach so that you could tell a computer to do all the hard work for you. Okay. Once we have the 1, what do we do to finish off our column? Go get 0s. And Adam's telling me how. He's saying multiply by the opposite and add. But what row is safe right now? Row 3. What rows need to be changed? All the other ones. But how? You guys get in the system? I'm going to multiply row 3 by 3. Yeah? Because don't I need 0s everywhere else to get RRE? We want that identity matrix. I'm going to multiply by, not positive 4. 4 plus 4 is 8. I need, oh, I already did row 1. So then row 2, multiplying by a -4. Oh, that's a B. I don't know. Adam, don't answer. Everybody else, what am I multiplying row 3 by to get row 4? Got it. Pause. Ready, set, go. I'll come behind. Ready, set, go. If you need to, go off to the side. Make little baby equations for each little formula. We're almost there, guys. It's a struggle, huh? 3-day weekend. Hang in there. Anything times 0 is 0. Can I show you guys a little bit of a strategy? Is that okay? Because this fraction, a lot of you are hating right now, right? If I have to deal with 8ths, I'm actually going to think about this guy as negative 8 over 8. I'm going to think about this guy as 16 over 8, and I'm going to think about this guy as 5 times 8 is 40 over 8. Why? Yeah. Did you notice once you have to go multiplying this entry in order to get our next one? 3 times 5 eighths, stink, 3 over 1, that's 15 eighths. It's okay, 15 eighths minus 8 eighths. 15 minus 8 is 7 eighths. It's okay. Negative 4 times 5 eighths is negative 20 eighths. Negative 20 eighths plus 16 eighths is negative 4 eighths. I'm just doing all of them right now. And then negative 11 times 5 eighths is negative 55 eighths plus 40 is negative 15 eighths. I know it's nasty, but I know that fraction is scary to some of you. And if you get the other numbers in eighths, it's not as bad. Hold on, I'm going to keep going. Sorry, I got distracted. But I know when you got to multiplying this guy and adding, it would be messy for you guys all along the way. Let me come back and keep going. So 3 times, I'm finishing off my row. 3 times 5 is 15. 15 minus 12 is 3. Give a little bit of space. With fractions, everything gets cramped really quickly. He's a little too close. Yes, I know that's negative 1/2. I'm just keeping it eighths for right now. Negative 4 times 0 plus 0. Haha. Negative 4 times 0 plus 1. Negative 4 times 1. We already did the 8th one. Negative 20 plus 18 is negative 2. Last row. Negative 11 times 0 plus 0. Negative 11 times 0 plus 1. No. Where am I going? Sorry. Here we go. 0 plus 0. 0 plus 0. Negative 11 times 1 plus 11. We already did the 8th one. Negative 55 plus 55 is. How are we doing? What do I need when I get down here to the last column? And you might be like, the last column, yeah, remember. These are just my answers. I need this to be my identity. 1x, 1y, 1z, 1w, and we're done. I need a 1. So if I need a 1, I'm not going to add. I'm not going to subtract. I'm going to divide or multiply by the reciprocal. Everything else is fine. I'm just on that bottom row. So 0 times anything, 0. 0 times anything, 0. 0 times anything, 0. This guy times his reciprocal, 1. 0 times anything is, well, that was nice. So now what? I have my 1. I need to get zeros. And the only way to get zeros is multiply by the opposite and add. The only way to get zeros is to multiply by the opposite of what's currently there and add. So what's the opposite of this guy? Negative 7/8. What's the opposite of negative 4/8? 4/8, yeah, I know it's 1/2. You can make it 1/2 if you want. I'm just being lazy. The opposite of 5/8 is negative 5/8. All right, let's see what happens. Oh, this is going to be awful. Wait, what's anything times 0? Plus? Okay, it's just 1. 0 plus 0? Oh, it's 0. 0 plus 0? Oh, it's 0. Negative 7/8 times 1 plus 7/8 is 0. Negative 7/8 times 0, 0 plus 3. Oh, it's not too bad. 1x equals 3. 4/8 times 0 is 0 plus 0. 0 plus 1. 0 plus 0. 4/8 minus 4/8, 0. Anything times 0 is 0 minus 2. Negative 5/8, 0 plus 0. 0 plus 0. 0 plus 1. Negative 5/8 plus 5/8. 0 plus 5. What does this mean? Ooh, looks so impressive when we do it that way. Well, you might start scaring your parents that you're going off into some weird numeric cult. But anyway, according to what I see, 3, negative 2, 5, 0 is our solution. How could we check to make sure we're right? Calculator, very beginning, RREF, what should you get? 3, negative 2, 5, 0. How else could you check that you're right? Come back here and say, if I took 3, negative 2, 5, and 0, 3 times 3 is 9, minus or plus 2 times negative 2, 9 minus 4 is 5, 5 minus 5 is 0, 0 plus 0 is 0. Oh, that one works. Double checking that I have them in my head, right? Yeah, 3, negative 2, 5, 0. 3 minus negative 2 plus 2, 5. 5, 3, negative 2, 5, 20. Sorry, 5 and 20 is 25. 25 plus 0 is 25. Yay! Guess what's going to happen when I plug in to all 4? Check and a check and a check, check, check. Sorry, no, check and a check and a check, check. There you go. They're all going to work. Why? Because it's my solution. Why? Because we did RREF, right? And the only way we simplify to an identity is if we solve for x and y and z and w. Guess what you just did? Practice how to make 1s and 0s systematically to solve any size system. What if it was a 10 by 10? You just keep going until you had 10 1s and 0s everywhere else. But the matrix, Gavin asked this, wouldn't be a 10 by 10, it'd be 10 by 11. Because you have 10 equations, 10 variables, but what do you have the whole time chilling out here and being manipulated the right way? The answers. Question? Oh, yeah, so you can see. Kathleen. When I was doing these ones, Okay. The nice thing is for these ones, remember we have to go entry by entry. So times and then plus, like times and then plus and then, sorry. The coefficient times row 4 plus row 1, or the coefficient times row 4 plus row 2, or the coefficient times row 4 plus row 3. The nice thing is, and why I went so fast, when I got down to here to multiplying by the 1, I'm in the 4th column. I knew that every time it was going to make a 0, a 0, and a 0 the way I wanted. And then why I went so fast is because when I went to go multiply all of these by the last entry, they were all 0 because of this guy. So negative 7/8 times 0, 4/8 times 0, negative 5/8 times 0 was always 0. So 0 plus 3, 0 minus 2, 0 plus 5. They all stayed the same. So for row 4, negative 7/8 times 0, 0, plus row 1. Or 4/8 times 0, plus row 2. Or negative 5/8 times 0, plus 5. They all just stayed the same because anything times 0 is just 0. Yeah. If it had been a number, you're right, I would have been doing a lot more math, and I probably would have been getting the 3, negative 2, and the 5 into 8s. Sam? Okay, I'm looking right here, right? 3 row 3 plus row 1. So 3 times 0 plus 1 is 1. 3 times 0 plus 0 is 0. 3 times 1 is 3 minus 3 is 0. 3 times 5/8 is 15/8. 15 minus 8 is 7/8. And 3 times 5 is 15, and 15 minus 12 is 3. Yeah. Now, guys, that was the worst example of the whole section. Do you see why we needed one more day on this section? What was true about the one we did yesterday? It was easy. But didn't we talk about how to get a 1 dividing, how to get a 0, multiply the 1 by the opposite and add? The steps were the exact same. We just expanded it, well, a lot. So what else is there in this section? Kiddos, what do you think we should do? What's wrong? It's small. Well, how many equations do we have? 3. But how many variables do we have? 2. So how do we put this into an augmented matrix? This is just weird homework help, okay? Weird homework help. But didn't we have weird stuff happen in systems in section, or chapter 7, whatever, with equations? Didn't we have like 0 equals 0 or 0 equals a number, right? So what would this augmented matrix be? Negative 1, 1. Why am I putting a 0? Because we have to make it with a little 3 by 3 over here. 3 equations, 3 unknowns. I know it's weird, but it's the way we got to go. It's the only way that RREF works. Then we're going to do 3 and 4 and 0z. Then we're going to do 4 and negative 8 and 0, 32. They didn't give us z's. All right, fine. We'll make our own and just make them zeros. Like we would do with long division, like we would do with synthetic division. If something's missing, we put zeros. So what do you think I'm going to do over here when this guy's the wrong size? With our augmented matrix. I'm going to do 1 and 1 and 4 and 5. I'm going to do 2 and 1 and negative 1 and 9. But I'm going to do 0 and 0 and 0 and 0. Why? They should have given them to me. Yeah, pretty much you're right. Pretty much you're right. Can I do RREF to this guy? Yep. But what's going to happen if this still ends up being zeros on the bottom? I'm going to let z equals a, and maybe I can't go all the way to 1x equals, 1y equals, 1z equals, but I should be able to use my RREF as far as I can get. Sometimes in your calculator, if you try RREF or REF, you're like, that doesn't look right. If it doesn't look right, it wasn't possible to get all the way because there was a let z equals a. So Robbie, guess what? Even in this homework, every now and then, you're still going to have to back substitute exactly in order to get your solutions because the calculator can't show you formulas with a. But it can simplify all the math so you have less plugging in to do. Same thing here. If you end up with something where you're missing your z, let z equal a and back substitute. Does that mean we shouldn't simplify him at all? I mean, you could just go ahead and back substitute, I suppose, the way it is, but the problem is The problem is there's a lot of math to be done. And so it might be just a little bit easier to do REF or RREF, REF or RREF, to make this all simpler and narrow it down and then be able to see what's going on. Now guys, once again, I'm just saying consider. Consider letting Z equal A, but only after you row reduce. We're going to see tomorrow what kinds of questions you guys have as far as how you did on homework, where you got stuck, etc., etc., etc. But let me see if there's any other hints, tips, tricks, weird problems I want to look at. Oh, don't worry. This is all just saying basically how we can, like weird ways to get matrices in, but you guys know matrix edit is a whole lot easier than what they're trying to say. Then they showed you things like row operations or row swapping. This is technically in your notes if you want to see how to do things like multiply this row by and then add rows, or multiply and then add, or anyway. If you want to look at it, it's going to be saved. Ooh, it's going to be saved. Hey, look, this is kind of what we're doing. We're doing like rows and putting. And anyway, what's weird about these? No. This isn't row echelon form. What's supposed to be here? A 1. And then we backset. So what should we do whenever we see 0, 0, 0? Oh. This one, RRE. No, it's supposed to be done, but it's not. Why? Do you see what could happen in your calculator or in your math? Okay, just a heads up. With that? Oh, why do I have this guy? Is he going to be weird or is he going to be normal? What do we do if we're missing an x term? We have to line up x's, y's, and z's. We can put zeros. That's what I wanted to show you on that one. That'll probably be a homework spiral one for tomorrow when you guys come in. Oh, is that all I have? Sorry, Tuesday, yeah. In my head, tomorrow just means next school day. I'm sorry, guys. We do have a 3-day weekend. All right, cool kids. For those of you guys that started homework, is there any place you got stuck that you don't think, just for the sake of those of you guys that didn't or didn't get as far, is there anything in particular that you would like us to look at really quickly, like me to give a hint on? Do you have an example of that, Adam? Okay, Adam's just warning us there could be a funny problem in number 102. Doesn't this look a lot, guys, number 102, doesn't it look a lot like section 7.6 when we were having to translate a problem in order to do constraints? Does that make sense? A city zoo borrowed $2 million at a simple annual interest. That's simple. I can't talk. I'm just going to stop. There's a paragraph of information, blah. What are we going to do with said information? Make a system. Like, I see them putting money in different accounts, right? So do you think maybe I can say, okay, well, all the money they put into the accounts needed to add up to how much money they needed, which was $2 million, right? That gets that one. Some of the money was borrowed at, use a system of linear equations. How much was, the total interest gotten from. So can't I say 0.08 times 1 plus 0.09 times another plus 0.112 of another is equal to? Do you guys see what I'm doing? And then they give us one more clue. You can leave. This will be on the video if you need this homework help over the weekend. Bye, guys.
Would that be 0.08
No. Careful. The amount borrowed at 0.08. The amount borrowed.
So x equals 2.
X was twice.
And then,
So then you can make this 1, 2, 3, go. Is that cool? Yeah. Yeah.